Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving here today, as it is every day, here in my virtual classroom. Step 1 as we jump into section 1.2 in the Big Ideas Math Integrated Math 1 textbook on solving multi-step equations. Now, in the intro section 1.1, we were solving simple equations. They normally just took one step. You added, subtracted, multiplied, or divide something from both sides of the equation. And I went pretty slowly through that, and we're going to get that one more at a steadfast pace as we do more two-step or three-step or however many steps it takes to then solve for that variable, solve for x, whatever it is. And I don't know, we're just going to go ahead and get started with this, with the lecture portion, and then we'll go to the problem set itself. If you'd like to find any information on this, you can go down to the description section. I have a PDF for this exact thing that I'm going to put up on the screen in a moment. And you can also find the timestamps that go to each problem or problem set within here, because I'm going to start with that lecture portion. It'll take a little chunk of time, and if you want to advance past this into the problem set, go ahead and do that, as I do 56, I believe, problems in this as a solution guide video. You can also find the playlist for Integrated Math 1 down below if you're trying to find other information with this. Without further ado, I'm going to go ahead and get started. We are going to solve multi-step linear equations using inverse operations and use those equations to solve real-life problems. And unit analysis, which sounds to me like something that I actually did this at least for one problem in the IM1 set, but if you didn't find it, I'm sure the lecture portion will now cover it here. Solving multi-step equations, you simplify each side of the equation if necessary, then use inverse operations to isolate the variable. Simplifying each side means what you probably think it means. Distributive property, get rid of parentheses, combine like terms. It's not always required, it's always recommended though. Sometimes strategically, if you know something else to do with it, go ahead and give it a shot. But for now, kind of follow that protocol. So in solving this two-step equation here, it says solve, for example, 2.5x minus 13 equals 2. We have to get this x by itself. Now, two things are affecting it. X is being multiplied by 2.5, and then afterward 13 is being subtracted, and that equals 2. So you really want to work backwards on what's going to happen here. If 2.5 is being multiplied by x first, and 13 is being subtracted last, to me that sounds like something minus 13 is 2. Doesn't matter if it's multiplied by 2.5 or not. So the first thing I want to do is the last thing that's done to affect x. 13 is being subtracted to get 2. We got to add 13 to figure out what that number was, right? 2.5 times some number is 2 plus 13. That's 15. So this is where you add 13 to both sides. And then 2.5 times that number, you divide both sides by 2.5. And 15 divided by 2.5 apparently is 6. You can still double check these. You would substitute 6 into the expression, and you know my phrasing if you heard it from the 1.1 scenario. When in doubt, use your damn parentheses. With your substitution, plug that baby in, that 6. 15 minus 13 is 2. 2 equals 2. It checks out. Now, as far as the instructions that we stated go, they asked to simplify each side. This side is already simplified. There are no like terms to combine here, and 2 is clearly already simplified on its own. So the solving step after that is getting the x term by itself, 2.5x in this case, and then solving for x itself through the undoing the multiplication, do the division. Second example, combining like terms to solve an equation. This is where simplification might have to be start off the problem. Negative 12 equals 9x minus 6x plus 15. Let's solve for x. But what's the first thing that they do? They combine like terms. 9x minus 6x combines to become 3x. Now, as you're maybe learning solving equations for the first time, you might fall into this rut, into this mishap, this habit. You say, like, I want to add 6x to both sides like this, and this is a big no-no. I mean, this is incorrect. I'm going to go and state that. 9x minus 6x, you see the minus, you say, I want to add, and then you find another term with x and you add it here. This is way wrong. I want you to think of a couple reasons why it is, but the main thing is lack of balance. You took one side of the equation right here, and you decided to add 6x to it twice, while the other side got no balance with it. I mean, literally all we're asking you to do is take 9x minus 6x. So please do the simplification first and combine those. Do not attempt to add something twice to a side that would unbalance the equation. Anyway, now that we got this down to a single term, you're asking yourself, how do I get this term by itself? Subtract 15 from both sides, and you get negative 27 over here. And that's when we can then divide both sides by 3 and get x equals negative 9. So as I said, I'd be going faster through this process and even talking about it. We are going to do double checks if they require it, and I'm guessing they will. So you double check with the original problem again. 9 times negative 9 is negative 81. Minus 6 times negative 9 is plus 54. Those add to negative 27. Negative 27 plus 15 is negative 12. That equals negative 12. It checks out. There are some monitoring progress problems. I always skip those ones because we're going to do a whole bunch later. I'm guiding you through the ones that they talk about. Using structure to solve a multi-step equation, we have an instance now with a quantity 1 minus x. Again, check your solution ultimately. They mentioned the distributive property here, so it sounds like it's something that you should have been taught previously. It's something I did bring up in the previous set. Whenever you have a quantity multiplied by something, you can multiply that something by each term in the quantity. A times B, A times C, both get multiplied, and then you add that result. You can do the same thing under subtraction here. A times B, A times negative C. I guess you subtract the result from that. But that's what we can do here. And they're saying method number 1, because I can think of a method number 2 that they're going to do. But let's talk about method number 1 first, which I would prefer for his. Distributive property. Multiply 2 with 1, multiply 2 with negative x, you'll get 2 minus 2x. Remember, 2x means 2 times x. And this is a case of simplifying. Distributing is a case of simplifying because it brings us to things that can possibly combine now. 2 couldn't have added with 3. 1 couldn't have added with 3. Not until multiplication happens first, right? It's kind of an order of operations thing. Once I did 2 times 1 to get 2 again, I can now add that 2 with that 3, and boom, you get your 5. And that's part of our simplification process for the problem. So now that we've simplified the left side of the equation, negative 8 stays as it is. We can now subtract 5 from both sides. 5 minus 5 is 0. Negative 8 minus 5 is negative 13. We divide both sides by negative 2 as it's multiplying by x, and we get the decimal value of 6.5, which is exact. Now they're going to double check, and it seems to all pan out. I'll leave it, but they do it again with the original problem. There is a second method, and I'll read what they state. There's a reason why I probably wouldn't do it for this problem, but I'll bring it up in a second. Another way to solve the equation is by interpreting the expression 1 minus x as a single quantity. We know we're solving for x, but because 2 is multiplying by that whole thing, my goal is still to get x by itself. I could divide both sides by 2 when I'm at that stage. Now notice that the first thing they did was they subtracted 3 from both sides, which is a wise decision overall. You get the quantity by itself, this 2 times 1 minus x, you subtract 3, you get negative 11, and from here you divide both sides by 2. 2 divided by 2 is 1, negative 11 divided by 2 is negative 5.5. That's one of the reasons maybe you don't want to consider it is you get a decimal a little earlier than you'd want. Look, the answer is the same. It's 6.5. We got 6.5 up here as well. But notice we didn't deal with decimals until, well, the very last portion where you just divided, maybe even use the calculator. But I didn't get any decimals before that. So why did this get a decimal? Because we divided an odd number by an even number. So what if this was instead a negative 12? Dividing by 2, would that sound good? Actually, it would. It would sound good. It's a way to shorten your values. That becomes negative 6. That's a different question. But, you know, if that's an even number, if this is divisible by that number there, it's a good method. And I'm going to explore that anytime that it seems like that's happening. I'll give that as a second alternative to, to what we're doing. Well, first alternative, technically. Anyway, what do they do from here? Obviously, getting x by itself, they subtract 1 from both sides because 1 here is positive. This x is still negative, don't forget that. And then they divide both sides by negative 1. Now, if you heard me in the last, I think there was only one problem I did it with. It was like a word problem. But in the last section, I also make this goal of attempting to get x positive early on whenever possible. So I might even add x to both sides instead of subtracting 1, make it positive to not deal with this hassle of dividing by a negative afterward or forgetting that the negative there exists. So it's up to you. It's up to what the problem is, but that's the second method. Before distributing the 2, divide it out so it's not there. Okay, solving real-life problems. Let's model with mathematics. Use the table to find the number of miles x you need to bike on Friday so that the mean number of miles biked per day is 5. Now, mean does not mean like angry, like upset. Mean means average. The average number of miles biked per day is 5. So we have to understand that concept. They're probably going to say that here. Let's see. Mean. Use definition of mean. Well, mean means average. It also means mean. Anyway, we're riding 3.5 miles one day, 5.5 miles the next day, then 0. Uh-oh, we're going to have to pick up the pace. Then 5 miles the next miles. I'm guessing it's going to have to be more than 5 miles. We're going to have to pick up that pace on Friday. So how do you find an average of something? You add up all your numbers and you divide by how many there are. So add up these 5 values, that includes x, divided by 5. So what we're going to ultimately get is a division problem. There's addition on top, but a division problem exists. It's a fraction. 3.5 plus 5.5 is 9, plus 0 plus 5 is 14. 14 plus x divided by 5 equals 5. Now, we saw, I think this is our first one with the fraction, but there are different instances of fractions we'll be able to see in solving. Think about the order in which x is being affected. First, 14 adds with x. and then that result divides by 5. So think about it. If the last thing that happens to get this 5 is dividing by 5, we have to multiply by 5 first to get rid of, to cancel it, right? 5 divided by 5 is 1. Actually, that's what they did right here. I should have looked at that. They multiplied both sides by 5 right here first, which is kind of like that dividing by 2 first in that quantity. 14 plus x is treated as a single number. So we're multiplying by 5 first, a wise decision. I would think nothing less of that situation. And then you subtract 14 from both sides and you get x equals 11. I'm sure we could do some double checks, but you need to bike 11 miles on Friday to get an average of 5 miles a day, which is quite a bit in comparison to what you were doing. Excuse me. So there's that one, and notice that it's a word problem, so we answer in units as well. Using unit analysis to model real-life problems. This is the same scenario. When you write an equation to model a real-life problem, you should check that the units on each side of the equation balance. So this is what I was talking about on a previous question in section 1.1, and I brought up the, what was it? I forget the situation. It was, oh, I cannot remember. I'm sorry. But it was something where it was something per something, an amount of something per something. I'm just going to make it up. I know this wasn't it, but dollars per gallon. Oh, you know what it was? It was number of eggs per carton, and we multiplied by the number of cartons. So what I showed was when you have, and I forget the numbers, I'm just going to make it up. When you have 12 eggs per carton. I think it was 18, but 12 eggs per carton, and you multiply by, say, 3 cartons. I'm just making it up now. You end up getting a result of eggs. That's 36, but that's eggs, right? 12 eggs per carton times number of cartons. Cartons divides with cartons. They cancel out. You're just left with eggs there. So then the units align. And what I stated as the thing was like, you can't add like pairs of shoes with dollar amounts and get number of, bones or something like that. You have to make sure that the units align ultimately and that the left side equals the right side. So 5 as an average was 5 miles per day. This was 14 plus x miles over the course of 5 days. So that is a miles per day. The per is the division portion of it. You can say out, you can say per, you can say out of, you can say in, I guess, like 5 miles in 5 days, something, or in a day. There are a lot of things like that you can do to represent that. But yes, you want to make sure that the units align. So in this example, in setting this up, you want to make sure that when you set it up, it operates correctly. Your school's drama club charges $4 per person for admission to a play. The club borrowed $400 to pay for costumes and props. After paying back the loan, the club has a profit of $100. How many people attended the play? So the how many people is our unknown. We could call that X, I suppose, and that's a number of people. So when you write out your set and you're trying to come up with this stuff, either saying it out loud or writing it, make sure that X people gets affected by whatever happens. Now, how many people attended is a portion of an equation where they charge $4 per person. If you have $4 per person and you multiply by the number of people, you ultimately get dollars from that scenario, right? If there are 10 people, 4 times 10 is 40. That's $40 out of the 4 people, right? But that's what we're doing through the multiplication. People cancel out, or person cancels out with people. You get 4x as a term. Now, $400 was a part of the what was borrowed to pay for this. So if you paid something, you got to deduce it from, there it is. And then boom, here's your amount of profit in total. Now, $4 per person times X people equals a dollars amount. 400 is a dollars amount. This is dollars minus dollars, and the result is in dollars. So now that we've had that, I think we can agree that that should be the equation to set up and then solve. So what do? Add 400 to both sides and divide both sides by 4. They get X equals 125. That's how many people attended the play. This is, once again, one of those things where, guys, the practice is whether or not you can do this in your head and you try and work it out. The goal is to set up the equation and then solve algebraically. That's what we're going to try and do. Okay, that's the end of the lecture portion. We're going to go into the vocabulary and core concept check, 2 questions only, and then we have numbers 3 through 56 to take care of. Number 1, complete the sentence. To solve the equation, 2x plus 3x equals 20, first combine 2x and 3x because they are, I'm going to say like terms. I don't know exactly what phrasing that they want. That's the phrasing I'm going to state. They're like terms, and 2x plus 3x is 5x. This isn't the word that they want, but they are simplifiable. You want to try and simplify each side of the equation, and you're probably going to hear me say that each time. First, simplify both sides. They're good. Let's move forward. That's something I'm going to be talking about. Number 2, describe 2 ways to solve the equation 2 times 4x minus 11 equals 10. Okay, so the 2 ways are method 1, distribute the 2 first. This is just the first step. Distribute the 2 to begin with, and method number 2 is divide by 2 to begin with. So if I distribute 2, then gone will be parentheses. You'll have the left side simplified in its own way. You'll have 8x minus 22 equals 10. I'm not going to solve the rest of the way, but 2 multiplies with both of those, and add 22, divide by 8 from both sides. The alternative method is divide both sides by 2, and I like the method for this one, dividing by 2, because 10 can divide by 2. You see, 2 is multiplying with the quantity. Forget that it's multiplying, that 4 is multiplying with x. If 2 is multiplying with something, it's twice as big as it was before. If you want to make it half its size, you divide it. But the thing is, I like that 10 can divide by 2 and get 5. You'll have 4x minus 11 equals 5. Now, that's probably a better version because the numbers are smaller, but you have to recognize that it's something you can do. If you're still practicing distribution as a whole, you want to get better at it, then I recommend you work on the distribution. It's foolproof, bigger numbers, but it is a foolproof method. This one strategically can work out to be better if you make things right the way they are. Anyway, that's questions 1 and 2, guys, in vocabulary and core concept check. We're going to move on to problems 3 through 56. Go ahead and whip out anything you need. Download this PDF, binder paper, calculator, and get ready to pause me as I move along. Keep in mind, what we did in section 1.1 applies to this section. I'll be doing that faster. The only slowdown here for me will probably be the double checking. Okay, so question numbers 3 through 14, they say solve the equation, check your solution. Now, as I'm looking at this, it appears that there's probably nothing I can simplify on either side of the equation. That's just the heads up. That's probably saved for the next set. Well, actually, it's probably saved for numbers 11 onward. 11 onward that we'll simplify first. So numbers 3 through 10, I don't think I can simplify anything before I attempt to solve for my variable. 3w plus 7 equals 19. W is multiplying by 3, and then 7's adding to it. We get 19. Let's first take 7 away from both of those sides to then determine what 3 times w is supposed to be. See, 3 times w is supposed to be 12, because 12 plus 7 would have given you 19, right? Now we can divide both sides by 3, because 3 is multiplying with w. 3 over 3 is 1, and 12 divided by 3 is 4, so w equals 4. They do say check your solution. So we will substitute 4 back into the original equation, 3 times 4 plus 7. Remember, your goal is to basically simplify your sides. 19 is simplified. I'm going to leave that as is. Let's keep working on this. This is 12 plus 7, and 12 plus 7 is 19. So that checks out. I agree with it. I'm good to go. Number 4. 2g minus 13 equals 3. Once again, the left side is simplified. There's nothing I can combine there. So as I attempt to isolate the exponential term, the variable term, I'm going to add 13 to both sides because that is the inverse of subtraction. And then I get 2g equals 16. 2g means 2 times g. We will divide both sides by 2 to get g by itself. And there we have g equals 8. Are we sure? No. Let's go ahead and check it. 2 times 8 is 16. 16 minus 13 gives you 3. And hey, that equals 3. I feel better about things now. Do you? I do. Number 5. 11 equals 12 minus q. Now, this is a problem, not an issue. This is a problem, a constructed problem, where in a lot of cases for me, I personally prefer to get my variable term positive before moving anything else with it. Now, I'll do this in 2 different ways. One method is subtracting 12 from both sides, but 2 hassles come into play. Number 1, you got to remember that there's a negative here when you write this next part out. So this is -1 equals negative q. And number 2, you got to do another step with it. We got to now divide both sides by -1 if you'd like to state that, or switch the signs. It's kind of up to you. Now, -1 divided by -1 is +1. Don't say cancel out. Hopefully you've heard me say that before. I'm going to go ahead and place q on this side now. -1 divided by -1 is +1. If that was a little too much for you, take a look at this version. My alternative to this would be adding q to both sides to begin with. I'm just stating get your variable term positive if you can. Does it combine with 11? No. And do you have to write a second step for this part? No. I can keep moving on forward with this, as I can also subtract 11 from both sides right now, if you'd like. And remember, both sides, I mean both sides of this equation. There's an equal sign right there, right? 11 minus 11 is 0. Negative q plus q is 0. Let's see if we have everything in order. That's a positive q here. 12 minus 11 is 1. I don't know why I wrote 11 then. 12 minus 11 is 1. And q equals 1. We get 1 either way. Let's see. Let's double check. Does 12 minus 1 equal 11? Yeah, does 12 minus 1 equal 11? Yes. Why they call it a multi-step equation? Because q is negative. I mean, it's you either have to make it positive and then subtract 11, or subtract 12 and then divide by negative, make it positive. So either way, it happens to be a multi-step with that. I prefer this, and it's not just, I mean, that problem's smaller to do it with. My goal with my variables is to get them positive. I think it saves hassle, personally. I do. I'm going to talk on strategy quite a bit. So let's do that on this problem. 10 equals 7 minus m. Let's go ahead and get that m term positive to begin with this time. Let's just do it once. Add m to both sides. Not that it conflicts with that 10, but in doing so, let's go ahead and subtract 10 from both sides at the same time. I hope that's okay. 10 minus 10 is 0, negative m plus m is 0, and you have a positive m on this side. 7 minus 10 is negative 3. Do you have to do anything with the negative? No, that's the answer. It's negative 3. Let's check that one. That's 10 equals 7 minus, and the 3 is negative. So substitute, use parentheses. Subtracting a negative is addition. And you get 10 equals 10, so it checks out. So again, don't make that 7 minus 3 as 4 and go, uh-oh, I messed up. Right? You don't want to mess up your double check. That would be bad. Number 7 is not something that popped up in the lecture. We did have fractions previously, but not of this accord. What this one is the fraction just with the variable. So z is dividing by negative 4, and there's minus 3. And listen, I don't like to think of it as a fraction. I think of this just as a single term, the same way that these were 2g was a single term, okay? It's just dividing. It's just dividing. I don't think of it as a fraction because I'm not going to do anything with the fraction. I'm not going to get a common denominator or anything like that. But hey, we got to get this thing by itself, right? So we're going to have to add 3 to both sides. I'm going to start with that. And now I have 8 equals z divided by negative 4. And they did stress it was a negative 4 as we get z by itself. We'll multiply both sides by negative 4 here because that'll give you 1z. And I'll write it on this side now. Negative 4 times 8 is negative 32. Seems like a big number. Let's see if that works out. Does 5 equal negative 32 over negative 4 minus 3? Negative over negative is positive. 32 over 4 is 8. And 8 minus 3 is 5. So those check out. Number 8 looks like the same kind of problem. Division, but only affecting the variable. First, a divides by 3, and then 4 gets added afterwards. So in isolating the term, we're going to first subtract 4 from both sides. 6 minus 4 is 2, so some number divided by 3 equals 2. What is it? You can multiply by 3 to figure it out. That value will be 6. That should be a's value. 3 divided by 3 is 1. 2 times 3 is 6. A equals 6. 6 divided by 3 is 2, plus 4 is 6. So we get 6 equals 6, right? 2 plus 4 equals 6. Okay. Now, the next two questions are different from these two questions that we stated here on numbers 9 and 10 because although there's division, division here in the order of how it's affecting your variable seems to happen last. Now, this did occur in the lecture portion for an example. H plus 6 divided by 5 equals 2. I need to solve for h. First, it adds with 6. You got to treat this as its single quantity. It's not one term, but both of them are being divided by 5. When you combine those, not like terms, but when if h was 10, 10 plus 6 is 16. It's like a number that gets divided by 5. So something divided by 5 is 2. We want to first multiply by 5 to figure that out. Do not subtract 6. 6 is being divided by 5. Not anymore. We just multiplied by it. So h plus 6 equals now 10. And then you can subtract 6 from both sides, the inverse of that addition, and solve that h was 4. It wasn't 10 to begin with. It was 4. Let's check that out. 4 plus 6 over 5 equals 2. There's my substitution of h. Notice you do 4 plus 6 first. You get 10. And 10 divided by 5 is 2. And there we have it. Trust the process. Trust the process. Number 10 is more of the same. We have a couple more negatives in the way, but that didn't stop me. Let's check it out. D minus 8. The only disappointment for me is no x's in this whole thing. Why aren't we solving for x? Come on now. D minus 8 divided by negative 2 equals 12. And listen, they are doing you a bit of a service by, okay, that was weird. By putting the negative 2 there. They're letting you know, hey, multiply by negative 2. That's not always going to be the case, guys. Fractions can end up in the middle of the problem in a strange way. Just make sure you keep that in mind. Negative 2 divided by negative 2 is positive 1. If you don't want to distribute to the d, don't let it. That's still d minus 8. This is now a negative 24. I'm going to add 8 to both sides of this equation to solve for d. Negative 24 plus 8 is not negative 32, but it's negative 16. d equals negative 16. Want to check it? Lots of negatives on this side. How could it possibly turn into this 12? Well, negative 16 minus 8 is negative 24. And a negative divided by negative is a positive. You do get 12 equals 12. Okay, this is still a part of that same set, but like I said, this was the barrier between what you didn't need to simplify and what you do. Now, that's not to be foretold each time you do a problem. That's something you should be checking for. So in these problems here, number 11, we have 8y plus 3y equals 44. And our goal is to solve for y, but y exists in two different terms, which can combine. Unlike the other sets of problems, I couldn't do d minus 8 and make it something simpler. I didn't know what d was. I don't know what y is either, but it's 8 amounts of y, 3 amounts of y. They combine to 11 amounts of y. You add the coefficients, combine like terms. Now the left side is simplified. Very simply, we'll divide both sides by 11. And we get y equals 4. The double checking measure here is substitution using parentheses, 8 times 4 plus 3 times 4. And I think that's a part of, what we want to bring up. 8 times 4 plus 3 times 4 is the same thing as 11 times 4. We generally don't do that. We generally just multiply these out. 32 plus 12, and that is 44. But you have to do that with variables because you don't know what that number is. It can't clean up more until you combine them. Number 12, 36 equals 13n minus 4n. Once again, something to simplify on the right side of the equation before we do any movement of terms or coefficients or anything like that. 13 minus 4 is 9, so 13n minus 4n is 9n. 9 is multiplying by n, divide both sides by 9, and we will get n equals 4. I'm going to write the n on this side. N equals 4. Let's check that one out. 36 equals... Boom, boom, boom. I'm going to stay silent. Maybe I got a little ASMR for you guys as I did that one very, very quietly. All right, that one checks out. I feel good so far in those first 10 problems. Number 13, more to simplify, more. 12v plus 10v plus 14 equals 80. Oh, you won't be shortened. Problems to attempt to do. What terms can combine? Only the ones with the v's in them. 14's a constant. We'll have to move it over at some point, but start with simplification. 12 plus 10 is 22. Now you have a simplified left side, and that right side's always been simplified. It's been waiting. It says, I've been waiting for you. We will do 2 more steps. We still have to subtract 14 from both sides. Bigger numbers to work with. 22 times v equals 66. That seems divisible. Divide by 22. 22 divided by 22 is 1. 66 divided by 22 is 3. V equals 3. Oh no, I ran out of room. And over here we have 36 plus 30 plus 14 equals 80. 36 plus 14 is 50 plus 30 is 80. 80 equals 80. I do want to let you know that the very moment they ask us to stop checking our solutions, I probably will. I want to make sure you know that. I know when we hit chapter review stuff, if they force it on me again, I will. On some word problems, they don't ask me, and I don't do it then. Unless I have a point to make on a problem. All right, number 14, 6c minus 8 minus 2c equals negative 16. Now, there's something I wish they did a little differently with the problem so I could talk about it. I'm sure we're going to hit it at some point in our math life. But 6c and negative 2c are the ones that can combine, right? And that's true. These are the ones to combine here. But what I want to make mention of that doesn't really work on this problem to talk about is that this is the minus we have to focus on for 6c minus 2c. It is not this 6c minus 2c. And I bring that up in such a way that what if this was a plus? Do I do 6c plus 2c? No. You still do 6c minus 2c. It's all about the sign of the term. 2c is negative. Okay, so these two will combine. They become 4c. Anyway, this wasn't relevant to the problem because both those signs were negative, so that was too bad. The 8 is still negative though, yeah? But we're about to add it over like this now that we've simplified this side, and negative 16 plus 8 is negative 8. Divide both sides by 4, and now you'll get C equals negative 2. Let's check it out. Negative 12 minus 8 is negative 20. Oh, I might have to write this one out because that's a lot of negatives to have happen. Negative 12 minus 8, this becomes plus 4. We're subtracting the negative, remember that? Negative 20 plus 4 is negative 16. Okay. All right, guys, that's the first set of problems on multi-step. Let's dive into a couple word problems with that same setup. They're not asking to double check, so I probably won't, unless there's something I want to talk about with it. Numbers 15 and 16. Number 15, modeling with mathematics. The altitude A in feet of a plane, t minutes after liftoff, is given by A equals 3,400 t plus 600. Notice the t looks different from the plus. Try and do that for yourself as well. Not make it look like plus plus or tt. How many minutes after liftoff is the plane at an altitude of 21,000 feet? Okay, this is going to be a substitution matter, and our goal is to solve for our time. T minutes after liftoff, we got to find out what that is. Now we're going to substitute. If A equals 21,000, 21,000 takes A's place. So 21,000 equals 3,400 t plus 600. Remember before when I said we had big numbers? Those were rookie numbers. Look at these. 21,000 minus 600 is the first thing I'd like to do here. Why? Because I'm trying to solve for t, and the right side of the equation has t. Let's isolate it, and this right side is already simplified. So I subtract 600 from both sides, and that is, it was 600, right? Yeah. And that is 20,400 feet in the air, and that's 3,400 t. And now we will divide both sides by 3,400. Now, I won't presume to actually know what 3,400 is. However, I'm going to wager a guess that it's an exact value, and if it is, it'll probably be 6. So let me do that in my head. 18,000 plus 2,400. So yes. So this will be 6. So t equals 6 minutes after takeoff. Will we be at this height? Now, if we were to make sense of this problem, because later we're going to have to come up with our own problems, things like that, the altitude t minutes after liftoff is given by this. I wonder where the plus 600 applies. I guess your plane's runway is 600 feet, not above ground, but altitude, is altitude the same as elevation? 600 feet above sea level maybe, and maybe that's what they're talking about. I don't know how the 600 applies specifically with this problem, unless they also mean elevation, but I was trying to just make sense of that little part. Okay, number 16. A repair bill for your car is $553. The parts cost $265. The labor cost is $48 per hour. Write and solve an equation to find the number of hours of labor spent repairing the car. Okay, let's let H be the number of hours spent. They said the entire repair bill is $553. So I'm going to put this as the total. If you understand how most repair things work, it's the cost of parts, cost of labor. Add those together. So that's what we're going to do. We have the cost of parts is $265. That's a flat amount. Doesn't matter how much time it takes to now labor them together, how much time it takes to do the repair. That's how much they spent on the parts themselves. That is just a constant amount, not affected by time. What is affected by time is the $48 per hour. And this is where we could talk more on units. I'm just going to say it out loud though. If you add now the total cost for labor, it's $48 for every hour times the number of hours. That ends up being a money amount. So this is dollars of total repair equals dollars of parts plus dollars of labor. Remember, it's dollars per hour times hours. This is where we can solve for H. There are a lot of different ways we could have written this. If I were doing this strategically, I'd actually say 48H plus 265 equals 553. No matter. This is simplified. We will subtract 265 from both sides of this equation. Excuse me. I had a big meal. Normally when making these videos, I'll have a big meal beforehand, and then I have the I gotta settle still, so I apologize if that happens. Maybe it's soothing, I don't know. It's not soothing to my body. Anyway, subtract these. This is where I could make mistakes. 287? No, 288? Listen, if it divides evenly here, then I'm going to trust that it's 288. 5, 6. H is 6. H is 6. Well, what are the units here? H was for hours, right? Number of hours? 6 hours spent laboring your car, repairing your car. So remember, there was an upfront cost. There was a parts cost that was not affected by hours, but the dollars per hour, therefore, was as a whole. They did say write the equation. We were able to do that and solve. Okay, in exercises 17 to 24, solve the equation, check your solution. This will probably take more than just what was probably 2 steps in the previous problems. After all, the section's called multi-step, solving multi-step equations. Could be 3, could be more. Now, for some problems like these, and I'll do this one in 2 separate ways. I won't always do it in 2 separate ways, depending on the scenario. But in this one, we have 2 different methods to work off of. One of them is classic distribution. We haven't been able to speak on this much, but 4 multiplies with z, 4 multiplies with 5. It's multiplying with the whole quantity. You're left with 4 times z plus 4 times 5. Boom. Now it's a simplified side of the equation. I never combined anything, but I did get rid of the parentheses. That was kind of cool. Now we'll do 2 more steps. As you well know, we can subtract 20 from both sides, and we can divide both sides by 4, because that's still multiplying with z. So divide that by 4. Let's see, let's just go back to blue. Divide both sides by 4, and we get z equals 3. Now, instead of checking my solution through substitution, I'm just going to do it a second method, and let's see if we get the same answer. If we do, I'll feel pretty good with my answer. We could also check mentally if that's okay. All right, the second method here is instead of distributing the 4, note that because 4 is multiplying by the quantity, that we can divide both sides by 4. This is 4 times bigger than it needs to be. Let's go and make it 4 times smaller than it is now, but that doesn't come at the cost of dividing by 4 here as well. Now, the reason I'm okay with this is because 32 can divide by 4. If it couldn't, I probably would not prefer this method. Z plus 5 equals 8, and the numbers became significantly smaller as a result when it comes to solving here. We subtract 5 from both, is one less step as well. Subtract 5 from both sides, and I get z equals 3. So they seem to be the same thing. That's going to be my double check if you also want to check this. 4 times 3 plus 5. 3 plus 5 is 8. 4 times 8 is 32. I feel good on it. Which method do I prefer? It depends. There are a lot of situations where this just seems right. It seems right to do. If you can recognize this for what it is in terms of making it 4 times smaller, perfect. The right side is really good. Not for every problem, but for a few of these problems, it will be. Maybe the majority of them. So maybe we look to do that as often as we can, but you can't do it at the wrong time. You can't do it too early without affecting certain other terms. I know that a lot of what we're doing right now is a guide to your solution. It's what to do correctly. There's a lot of what to avoid, and that's something you're going to have to be very careful with here. Let's do this one through distribution here again. We have negative 2 times 4g is negative 8g. Now this is where you have to be careful. The negative 2 is still distributing into this term, and that's a negative 3. That means this becomes a plus 6. So distribution of the negative into a negative gives you a positive. 2 more steps to go as we subtract 6 from both sides. I know I talked before about, hey, let's make this term positive. I think I'm going to save that now for if we have variables on both sides of the equation, and that might be an entirely different section. It might be the next section even. So we'll probably save that strategy for later, but just be mindful of it if I talk about it for different problems. We'll divide both sides by negative 8, and 24 divided by negative 8 is negative 3. Let's check that again by doing the other version of this, and then here on out, I'll only do one version or the other based on what seems best. I'll default to distribution unless it seems this can divide pretty evenly. And in this case, it can, right? We divide by negative 2. Hey, 30 can divide by 2. It's okay to turn negative. We are left with 4g minus 3 here. Remember, these problems are a lot like the division problems where we start with something that we divide by, and then we got to multiply to get rid of the fraction. This is just the other way. This is negative 15. We still have 2 more steps to go on this one, though. We're going to add 3 to both sides to get the 4g term by itself. And then we divide both sides by positive 4, excuse me. Now this time the g was a positive term. Maybe that felt better for you on that. So g is still negative 3. That checks out. I'm going to go ahead and say that that's a good double check for myself doing it twice. I think you'd agree. I think that's okay. All right. Number 19. See if there's one. See, double checking, plugging the number back in, sure. Double checking by doing a different method, I think that's even cooler. Number 19. 6 plus 5 times the quantity m plus 1 equals 26. Now do not do 6 plus 5. 5 is multiplying by something. Order of operations states you do multiplication before addition. So you have options here, once again. If you can't recognize immediately that dividing by 5 will pan out for you, because I'm recognizing whether or not it can, but I'm one step ahead. If you can't recognize that, don't do the division thing. You definitely don't do the division thing now. You're not like, let's divide by 5. Guess what? That 6 was supposed to divide by 5 as well. And now it's a weird fraction. You might not know, so therefore you're like, all right, let's just distribute. So let's go ahead and do it this way this time, straight up distribution only. I have 6 plus 5 times m plus 5 times 1, and I get 26. Now I have like terms that can combine now that they're out of parentheses, and 6 plus 5 is 11, so this is 5m plus 11 equals 26. Now I'm 2 steps away from solving if you've recognized that, that's where we're at. Subtract 11 from both sides to get 15 over there. 5 times what number is 15? We can divide by 5 to figure that out. That will be 3. Been a lot of 3s and negative 3s lately. I hope you're okay with that. It's one of those like multiple choice test things where you're like, I'm getting B each time. Is that okay? Are they tricking us? Maybe it's supposed to be a different answer. I'll write a different one. Let's double check that. This is 6 plus 5 times 4. Notice again, you can't add the 6 and 5 to begin with first. And 6 plus 20, which is 26. Now, was there a way we could have divided by 5 and made this happen? Yes, the way that I mentioned was divide 6 by 5, that by 5. Yes, that would have been weird fractions or decimals. I wouldn't have liked it. What you also could have done was actually subtracted 6 from both sides to begin with. But if that subtraction is too big, too cumbersome, too weird, and then you don't know beforehand whether that number can divide by 5 up front, I'd avoid trying it, right? That might be a little too much for you. Number 20 is a prime example of when I definitely would not be looking to do it here. So 5h plus 2 times 11 minus h equals negative 5. Okay, in this case, I'm going to be dividing by 2, but even moving this term over here wouldn't help because that has an h in it. It can't combine. So this is definitely where we're going to distribute first. No question. I wouldn't try any other situation than this. Let's distribute the 2. We get 22 minus 2 times h, and that equals negative 5. Now, as far as simplifying, I have a 5h and a negative 2h. They combine to become 3h. Here's my plus 22. Still 2 steps to solve. Subtract 22 from both sides. Divide both sides by 3. After you subtract 22, of course. One step, and then the other step. Ends up becoming multi-step, right? It's a lot more steps. You want to trust that every little part you did was correct. One little false step of forgetting a negative or saying 27 divided by 3 is 7 or something like that instead can get you in the wrong stage. But that's where we can also do a double check. We have multiple places to insert h here as well, by the way. 5 times negative 9 plus 2 times 11 minus negative 9 equals negative 5. I almost feel like the double check of this problem is harder than the original problem itself. 5 times negative 9 is negative 45. 11 minus negative 9 is 11 plus 9, right? So that's 20. This is negative 45 plus 40, which is negative 5. So it does seem to work out. Again, though, it's one of those things where what if I mess up double checking? Then I think my answer is wrong, and I try and right a wrong, and I end up wronging a right. And I don't know. Just be very careful. Number 21. 27 equals 3c minus 3 times 6 minus 2c. Now, this is a problem where, and I'm not going to do it this way because I think it would get people too weirded out. I could divide by 3 right now if I wanted to. You see, moving the 3c over wouldn't help. But dividing by 3 would, as long as every term divided by 3. Yes, I could do this. Divide by 3, divide by 3, divide by 3. There are a lot of issues with this, though. Nothing that's wrong, but something where you're going to mess up. First of all, yes, you would get 1c here and a minus 1 here. But this is still in parentheses, which means you'd still have to do that. There's a lot of things with that make it difficult. That's not wrong. It's not wrong. But boy, will a lot of wrong things happen, and that's tough to recognize. I personally wouldn't go about doing it that way anyway. I would just, no. Let's just do the distribution. Now, the part that you have to be careful on here, I understand if you were all good on distributing the negative on this question, number 18, you're like, oh yeah, it's a negative 2, totally, yeah, we're going to distribute that thing, and it's a negative 2 both times, right? right? This is where people will forget to do it. How come? Because you might just see this as a minus. 3c minus 3 times this and 3 times that. Hey guys, negative 3 is distributing into both terms. Don't forget it for both terms. So 27 equals 3c. Negative 3 times 6 is negative 18. Negative 3 times negative 2c is positive 6c. If there's a mistake to be made, it will be there. A lot of people will write minus 6c because they'll say minus 3 times 6, minus 18. 3 times negative 2c, minus 6c. Nope. All right. Anyway, let's proceed with the problem. 3c plus 6c is 9c as we combine and simplify that right side. Now let's get this term by itself by adding 18 to both sides. Shall we? That's 45. What's 45 divided by 9? 5. Okay. So that division thing could have been had. It's not recommended on a situation like that. I doubt even they'd recommend it because this wasn't its own quantity on its own side of the equation. There was still another term. It gets weird. It gets really weird there. Okay, let's double check that one. 3 times 5 minus 3 times 6 minus 2 times 5 in parentheses there. So this is 15 minus 3 times, that's 6 minus 10, so that's negative 4. Negative 3 times negative 4 is positive 12. 15 plus 12 is 27. And that checks out. I hope you're okay with me writing the C on this side afterward and doing this on that side. I started to do that in this section. I said it out loud in the first section. I would begin doing it. And here it is. All right, number 22. And this isn't the end of them. On the next part is 23 and 24. You can see we go 17 to 24. So we still have more to do. We have negative 3 equals 12y minus 5 times 2y minus 7. Now again, these numbers don't divide by 5, so we're straight distribution again, guys. There's really no change from this problem and the previous problem we just did. So let's get on through it. 12y, negative 5 times 2y is negative 10y. Negative 5 times negative 7 is positive 35. And I can combine like terms here with the 12y minus 10y to get 2y. So remember, everything we're doing is algebraic. Even if we come up with a word problem in this scenario, you can see why setting it up first and solving algebraically is really the way to go. I'm going to subtract 35 from both sides. Right? The goal is to get this y by itself one step at a time. Multi-step. And we get negative 38. And then we divide both sides by 2 now. And 38 divided by 2 is 19. But negative 38 divided by 2 is negative 19. Hold on, I got a little buzz on my phone. Make sure it's not something to... I don't know what notification I got. I have no idea. Y equals negative 19. Now, we could double check that. And I suppose we will. They told us to. But, hey, it's bigger numbers. At some point, you probably say, I think it's... I hope it's good. I hope it's good. 12 times 19. 228, negative 228. Minus 5 times 2 times 19 is negative 38 minus 7. Is that right? All right, let's see. Negative 3 equals negative 228 minus 5 times negative 45. All right, this is plus 5 times 45 is 225. Yeah, negative 3 is negative 3. Once again, probably a situation where double checking was probably harder than actually solving. All right, 2 more in this stage. We have numbers 23 and 24. This is where, again, I think distribution is just kind of the way to continue the rest of these problems. Number 23, negative 3 times this quantity plus 4 times this quantity equals negative 4. Now, there are 2 different items to distribute, right here and right here. First set's negative, like this, and then positive 4x plus negative 24, or negative minus 24. Okay, there's more simplification to be had here, right? We can combine like terms, and there are 2 sets of terms that can combine. I have negative 3x and positive 4x. Those combine to become 1x. I can just write x. Negative 9 minus 24, remember, it's this minus here, is negative 33. And then I just have to add 33 to both sides. Luckily, that was a positive x there, so I'm just 1 step away. And it looks like we'll get 29. Kind of a random sounding answer to me, huh? Huh? Yeah. I'm going to try and double check this mentally if that's okay. 3 plus 29 is 32. 32 times negative 3 is negative 96. Plus 29 minus 6 is 23. 4 times 23 is 92. And that's negative 4 is negative 4. I didn't fully. Yeah, as long as I'm checking, right? Number 24. More of the same. I was glad to have an X. Now that's gone. Number 24, distribution. Go ahead and try this one for yourself if you haven't tried one yet. Be very cautious of how this negative is going in, so I'm glad they're doing one like this. Give it a shot. All right, minus 2, negative 2 times 1, negative 2 times negative r. Positive. Positive. Okay, and combining like terms, 5r plus 2r and 45 minus 2. Again, we're simplifying this side before we move anything over. We use inverse operations when we move terms over, and that's going to be now. Subtract 43 from both sides. We get negative 42, which is divisible by 7, which is great. 7r equals negative 42, and then we divide. We get negative 6. Does that work? Negative 6 plus 9 is 3. 5 times 3 is 15. 1. Let's do this all at once. 1 minus negative 6 is 1 plus 6, which is 7. 7 times negative 2 is negative 14. 15 minus 14 is 1. Okay. All right. Hopefully that felt okay, at least as we progressed over time. Let's go to these geometric looking questions. In exercises 25 to 28, find the value of the variable, then find the angle measures of the polygon. Use a protractor to check the reasonableness of your answer. I said this in section 1.1. Look at me, look at me. I'm the protractor now. So I'm going to say if something looks like it's okay as answers. Now, they help you out in this situation by telling you the sum of the angle measures in this first set of problems. In this first problem, this triangle, the sum of the measures of a triangle. This is true of any triangle, by the way. The sum of the measures of a triangle is 180 degrees. When I add 45 with 2k and k, I get 180 degrees. Now, when it comes to an answer, because they said use protractor, and again, I said this in the previous section when they did it, that means these are probably pretty drawn to scale. So I imagine this angle, which is less than 90 degrees as k, is probably going to be somewhere around 45 degrees. Maybe it's going to be exactly 45 degrees. It probably makes sense. This looks like it could be an isosceles triangle. This is 45, that's 45. I'd believe it. Let's figure it out. Let's combine like terms. 2k plus 1k is 3k. And yes, that is a 1k. Simplified. Subtract 45 from both sides. By the way, they don't say double check, but they do say find the measure of each angle. Find the angle measures of the polygon. So after we solve for k, we still have to figure out what all those angle measures are. So this is 135, and yeah, you divide by 3, you get k equals 45. That feels right. I'm a protractor. I like it. Looks like a good answer. Now, as far as the angle measures are, we have a 45 degrees already. The other k is going to be 45 degrees. And then 2 times 45 is the other one, 2k, that's 90 degrees. So these are the three angle measures, 45, 45, 90. Looks hideous, though. All right. Okay. I don't know if that's how they want us to write it. Because they don't name the angles. They don't say angle A is this, angle B is that. Number 26. Well, I don't know. Let's see. We have the sum of angle measures is 360 degrees. When I add this 2a, this 1a, this 2a, and this 1a, I'm getting 360 degrees. All quadrilaterals out of 360. 2a plus 1a is 3a, plus another 3a there is going to be 6a. Divide both sides by 6. 360 divided by 6, it's like 36 divided by 6, but add a 0 at the end. A is going to be 60. A is 60. Do I believe it? When I rotate my head around, it looks decent, especially because 2a is doubling that angle, and that looks more than 90. So I'm going to trust that for what it is. Now, the angle measures of the polygon are going to be, I guess we probably have to draw them, if that's okay. So 60 degrees here, and 2 times 60 is 120 degrees here. When you find the angle measures, by the way, guys, you do need the degree symbols. Not for your variable, but you do for the degree measures. Number 27, ooh, we have a fraction. Number 27, we have the sum of this pentagon, and the sum of a pentagon adds to 540 degrees, at least the interior angle sum. So I have a 2b minus 90. That's treated as one angle measure. They put parentheses for the degree's sake, but I want to make sure that you see that that's representing one angle measure. Plus 3 halves b, plus b, plus b plus 45, plus 90. All together, they add to 540. Now this is interesting. There's quite a bit to handle here, specifically the 3 halves b. Now 3 halves b, I'm trying to think of how I want to talk about this. 3 divided by 2 is indeed 1.5. That's something you can do. I'm thinking about doing other things with it. For now, guys, let's leave the 3 halves b right here and ask ourselves later, what do you want to do with that? Now remember, these parentheses actually have no bearing on this. There's no distribution. It's just stating it was a single quantity, but we're still adding them. So what do I have here? I have a 2b plus, and remember, ignore this one right now. I have 2b plus 1b plus 1b. That's an extra 4b. I have negative 90 plus 90, which is 0, plus 45, which is 45, and this equals 540 degrees. Now, outside of these two b's that still need to combine somehow, we have like terms combined and simplified. So what would you like to do with this? 3 divided by 2 is 1.5. We can do this, 1.5 plus b plus 4b. This is a fine one. Does it always work? No. What if it said 2/3? Suddenly it's not an exact decimal. It's something you'd have to round. So this won't always work. So here's an option. Oh, where's b? 1.5 plus 4 is 5.5. So 5.5b is what happens there. There's the magic. Now that I've simplified this side, it's probably best I subtract this 45 over. And I get 5.5b equals 495. And then you divide both sides by 5.5. I think it's 90. Would that make sense as an answer? That, I think so. You know what? It looks like a home plate to me, so I'm guessing that's a 90-degree angle. So I'm going to say that that is 90. So b equals 90. B equals 90, okay? Now, that was one approach to doing this problem. Boom, right there. Two other approaches, which I'm probably not going to do the other ones in full, but another approach is work on these as fractions, meaning you'd have to turn 4 into, let's say, 8 over 2. Now 3 over 2 plus 8 over 2 is 11 over 2. So you'd have 11 over 2b. You would multiply both sides by 2 over 11, ultimately, when you're working out how to solve that, right? So that's another version of that. A third version of it is this, and I don't know if you would see this for what it is, but it kind of reminds me of the quantity thing from before. And this is the time I would do it. Take both sides and multiply by 2. Remember when we took quantities to divide by 2 to get rid of the thing out in front? This would get rid of the 2 down here because 2 divided by 2 is 1, but 2 would still have to distribute into 4b to become 8b and 45 to become 90, and this would have to multiply by 2 to become 1080. A consequence of busting fractions sometimes is bigger numbers, and which one would you like to deal with more? Personally, I like to bust fractions more, so I'd probably like to do that one more. Because this number is so small and so minuscule and it's an exact decimal, I'd say this approach is fine. We got 90. That's all good. When it comes to the official markings of degree for this home plate, think home plate, you think baseball. Well, for a home plate, we have 2b minus 90. 2 times 90 is 180. Minus 90 is 90. This one was already 90 to begin with. This b is 90 as well. 3 halves b. What is 3 halves times 90? 90 divided by 2 is 45. 3 times 45 is 135. So 135 degrees here. And if all's well, this should be 135. It's 90 plus 45. Yes, 135 degrees there. So that's the markings of all your angle measures. All right, and finally, number 28 from this set, we have a hexagon. Maybe not a regular hexagon, but it is a 6-sided shape. The sum of the interior angle measures is 720 degrees. Probably a little bit easier of a problem because no fractions. Let's start with that leading x and go around. 120, 100, 120, x plus 10, with or without parentheses, and 120. Together they add to 720. Combine like terms. I have 1x plus a second x, that is 2 x's. Let's add some of these up. 120 plus 120 plus 120 is 360. plus 100 is 460, plus 10 is 470. Subtract, oh, let me not skip any steps. I apologize if I did this from the previous problem. Subtract 470 from both sides, and you get 2x equals, is that 250? And divide both sides by 2, you get x equals 125. Does that make sense? Does my protractor mind make sense of that? My old look at me on the protractor now does not be able to see, I cannot see that the same way that it was before. I think we could double check and see that everything actually adds to 125, but I think it's looking good. It's one of those, look, okay, fine. You want to use a protractor? Here we go. With the protractor, we can measure this up against, say, this x like that. And if it's close enough, then I'm going to take it for what it is, right? If there was one small miss somewhere, I'm not going to be able to seek it out. But anyway, this right here, let's see if that looks close enough to become what it is we want it to be. Is that about 125 when drawn to scale? Oh, look at that. Look at the protractor now, guys. 125 degrees. Hey. All right. So that looks like a good answer. So as far as the entirety of the hexagon, what do we got here? All right. We have the 120 degrees here. X was 125. So there's degrees. 120, 100, 120, and 125 plus 10 is 135. All right, there you go. Okay, let's move forward. Let's get rid of this angle. Okay, numbers 29 to 34. Write and solve an equation to find the number. Okay, so they didn't really prep us for this. So it is, once again, my guess that somewhere along the line you learned this. Some other big ideas math thing. I'll do them. Yeah, I'll talk about them, but this isn't like, hey, remember the lecture when we talked about it? Not really. Whenever they say a number, guys, I'm going to use the letter X. They said find the number. They said solve it, so ultimately it doesn't matter what the thing is, but I'm going to use X in its place. They might use N if they talked about this, if your teacher talks about it. The sum of twice a number and 13 is 75. Okay, when you hear the sum of, you're thinking addition. I'm going to add two things. What two things am I going to add? I'm going to add this and that. Well, the first this is twice a number. The number's unknown and we have to get twice that number. So the sum of this and this is 75. Now this is an expression, the sum of twice a number and 13. The word is to us actually means equals. So the sum of twice a number and 13 is 75, is the divider of the equal sign between one expression and the other expression. So this equals 75. That's our setup. We subtract 13 from both sides, then we divide both sides by 2. I'm not going to double check my answers on these, by the way. They don't ask me to, and I'm going to trust my own work. So I get 62, and then we divide both sides by 2. We get x equals 31. So the sum of twice 31, 62, plus 13 is 75. I agree with it. It works out. Number 30. The difference of 3 times a number and 4 is negative 19. By the way, they also could have said triple a number, right? The difference of, when you hear difference, you're thinking subtraction. We're going to subtract two things. We're going to subtract the first thing and then the second thing. And there's a difference between saying the difference of 5 and 3 and the difference of 3 and 5. The difference of 5 and 3 is 5 minus 3. Difference of 3 and 5 is 3 minus 5. Those are two different answers, right? So the first thing they talk about is 3 times a number. Here's 3 times that number, and here's 4. That's the difference we're talking about, the difference of this and that. And it is negative 19. So we solve. 4 is subtracted. We're going to add 4 to both sides, and then we divide both sides by 3. Now this is negative 15, not negative 23, which is good for us. It's an integer answer. Divide both sides by 3, we get x equals negative 5. That's the number that we can triple to get negative 15, of course, and then subtract 4 from to get negative 19. Number 31. 8 plus the quotient of a number and 3 is negative 2. Now 8 plus sounds as direct as you can get, literally 8 plus. Now they say the quotient of a number and 3. Quotient is division. Quotient is division. So we're going to divide a number, x, by 3, and that will be added to that 8, and that is negative 2. So there's your setup. Our 2 steps this time, get this term by itself by subtracting 8 from both sides because 8's a positive number there. So we do our subtraction. And then we get just x divided by 3 here. Remember, you might see that as a fraction, but it is division. These subtract out, you get negative 10. We multiply both sides by 3. 3 divided by 3 is 1. Negative 10 times 3. Remember, 3 is multiplying with x, but dividing by 3. Negative 10 times 3 is negative 30. Yes, 8 plus negative 30 thirds. 8 plus negative 10. 8 minus 10 is indeed negative 2. I'm saying I won't double check, but, you know, the mind does what it does, right? Number 32. The sum, once again, it's an addition, but of two things. The sum of twice a number, it sounds like the number 29. The sum of twice a number, and half the number is 10. Okay, so half the number is the same number we're talking about, x. How do you take half of a number? You can say divided by 2. You can say multiply by 1/2. You can say 0.5 times. Let's do this one this time. You know, this probably is a good time that we can talk about that other method that I brought up, right? Where in here, if you want to make everything 2 times bigger because you don't want to deal with fractions, you can. 2 plus 1/2 is 2.5. I get it. I do. It's fine. Or 2.5, right? But let's say that I don't want to deal with fractions no more. I'm good with them. We can multiply this whole side by 2 and this side by 2. And remember, in a quantity, it's like distribution. 2 needs to multiply into both parts. Well, 2 times 2x is 4x, and 2 times 1/2 is, well, 2 times 1 divided by 2. That's 1x. So 4x plus x, and 10 times 2 is 20. As long as you do one thing to one side, you got to do the other thing to the other side. You can keep it balanced. You're all good. This is an equivalent equation, not the only way to solve it. Solve using your own method. I don't care. This is the one way I want to show this time. 4x plus 1x is 5x, and I can divide both sides by 5. Remember, my goal is to teach, and if you see a method to do something, sometimes this is best. Was it here? I don't know. Was it a way? Absolutely. And I want to present it when I feel like I haven't before. Number 33. 6 times the sum of a number in 15 is negative 42. All right, this one gets a little bit trickier. This one's trickier because notice it says 6 times the sum. So 6 times, okay, simple, right? 6, you can put a dot, you can put parentheses. I'll put parentheses here because we might want them. It says 6 times the sum. We're multiplying this. 6 times this breaks up the end of the expression. The sum of a number in 15. We know that a number in 15 added together, or the sum of that is them added together. We're doing 6 times the sum, guys. That means the sum happens first. First meaning parentheses in order of operations. It's not just 6 times the number plus 15. If they wanted this would they would say the sum of 6 times a number in 15. They said 6 times the sum of a number in 15. Gets tricky. Now this is negative 42. Now, we haven't done this method in a while, so let's look back at it. 42 can divide by 6, right? So let's divide both sides by 6 instead of distributing, and it probably saves you a little bit. 6 times 15 is a little bigger of a number. Maybe you don't want to work with that. So now we have x plus 15 equals negative 7, and we can subtract 15 from both sides. And this x is negative 22. Doing my mental math up there, it does work out. We're correct. Number 34. 4 times the difference of a number and 7 is 12. This is like 33. We're doing 4 times that difference. That means the difference needs to occur first, then we do quadruple that amount. So 4 times the difference of a number and 7 is 12. Now, are there different kinds of problems we can make other than these and make it tricky? Absolutely. By the way, 12 can divide by 4. Why not do it again? We hadn't seen it for a while. Let's work about it this way. We have x minus 7. No parentheses required anymore. It's multiplied by 1. And we can add 7 to both sides. 3 plus 7 is 10. X equals 10. 4 times the difference of 10 and 7. 4 times the difference of 10 and 7. Oh, I got to take the difference of 10 and 7. That's 3. 4 times 3. That's 12. That works. All right, that's 29 to 34. Let's move along. Looks like conventional problems are now down the gutter. We are now doing word problems and such. And we still have 22 problems to go. Number 35 to 37, write and solve an equation to answer the question. Check that the units on each side of the equation balance. Okay, this is something that we were bringing up before, right? During the summer, you work 30 hours per week at a gas station and earn $8.75 per hour. Okay, so that sounds like the amount of money I make from that alone is I take the $8.75 for every 1 hour per hour. And if I multiply by that 30 hours, then I'm getting, ultimately, a dollar amount. Because hours here are technically dividing by hours there. Hours over hours cancel out. What are you left with? Dollars. This is now a dollars amount as a whole. We haven't multiplied them yet, but we will, and we'll get a dollars amount from that. Is that all the money we make? No, you also work as a landscaper for $11 per hour and can work as many hours as you want. You want to earn a total of $400 per week. How many hours must you work as a landscaper? So we need to combine the amount of money we make at a gas station with the amount of money that we make scaping land. I was going to say mowing lawns. So scaping land, where it's $11 per hour times the number of hours here. This one I'll just call X, times X hours. That'll be money made by landscaping. So in total, that'll be a certain amount of dollars. That amount we want to be 400 when we combine the two. Dollars plus dollars equals dollars. Right now I'm in agreement. It says check the units on each side of the equation balance. These are balanced. Dollars plus dollars equals dollars. And that happens by canceling out hours when you do rate times time. Okay. Now 8.75 times 30. I don't want to mess that up. So I'm going to calculator ahoy. That's $262.5. So $262.50. But we're still working on this. This is 11 times X. By the way, why am I setting up the equation the way that I am besides the units? X is an unknown for us. We can landscape as many hours as we want, but we want that number of hours to give us $400 ultimately. So that was our setup. Multiply the dollars per hour times that unknown. So let's solve for X. We're going to subtract this from both sides. One of those things I don't want to make a mistake on again, but I'll try. 140, 130, 137.5. All right, even if that was it, I don't know what that is. Oh, I think it's 12.5. I think it's $12. Let me check this. 137.5 divided by 11. Aha, 12.5. So X, dividing by, I'm sorry, you don't know what I'm doing. I'm dividing both sides by 11, and that divided by 11 is 12.5. So what are we saying with that? How many hours must you work as a landscaper? To get $400, you must work 12 and a half hours. Remember, this is hours. That's not money. You must work 12 hours, 30 minutes. Hours as a landscaper to get $400. Okay. All right. Now, I say this thing quite a few times depending on what I need to do and such. I want to check on what that notification was on my phone because there was something that I might have to respond to. Give me a second. All right, anyway, so I've resumed. It's weird that I say let me pause for a second. It means nothing to you, right? Because I pause and come back. Bloop, a second goes by. Now, I checked the score, man. Extra innings going on. All right. Number 36. The area of the surface of the swimming pool is 210 square feet. So this whole 210 square feet by length times width. What is the length D of the deep end in feet? Okay, when you look at this swimming pool, let me do this. Give me a second. I'm going to copy and paste this diagram over. When you look at this swimming pool, we're talking area. It's a rectangular swimming pool. We're talking length times width. So when I consider this area being length times width, the width of this is 10 feet. The length of this is the combination of the deep end and the shallow end. The length is D plus 9. So as far as substitution goes, area is, I'm going to put the 10 first. Width, 10 times length, like this. Now the area is also 210 square feet, and it's surface area, but surface area is still area. So 210 equals 10 times D plus 9. Now, what they wanted us to do, actually, I kind of messed this up. What they wanted us to do was have units involved. So let's start with that. 210 square feet equals 10 feet of width times d plus 9 feet in length. Now, this is where we're multiplying feet with feet, and feet times feet equal feet squared to the second power. That's what exponents mean, multiplying something to itself. It even applies with units. That's where square feet come from. So that setup is magnifico. Chef's kiss. Very good. Hey, I could distribute 10, but hey, I could also divide by 10, right? So I don't want to stop that train whenever we have an opportunity, because it's not going to happen all the time. Trust me. 210 divided by 10 is 21, and we get d plus 9. Maybe in this section it'll happen a lot. I don't know. Subtract 9 from both sides, and we get the length of the deep end of the pool to be 12 feet. D equals 12 feet. I'm going to place the feet there. That's all. I'm not going to write a whole sentence on that one. So the units match. We're all good to go. Number 37. You ordered 2 tacos and a salad. Ooh, this is real life application. Sounds like something we'd do. 2 tacos and a salad. The salad costs $2.50. You pay 8% sales tax and leave a $3 tip. You pay a total of $13.80. How much does 1 taco cost? Okay. So X is the cost per taco. We don't know how much they cost, right? But we ordered 2 of them. So 2 tacos times the X dollars per taco, per 1 taco, right? Tacos divided by tacos will now equal dollars. Even the 2 is part of the tacos portion, but 2 will multiply by the X, so this is a dollars amount. So far, so good. Dollars here. We spent this much money on tacos. We also spent this much money on salad, $2.50. That is dollars. So dollars plus dollars is so far so good. Now, we also leave a $3 tip, but that comes after tax. So tax, you pay 8% sales tax. This part's a little tricky for a couple reasons. Number one is how to represent 8%. I'm not going to get deep on this part. Obviously, it's something that they expect you've done before. This is the second time I've seen something on percentages. 8% is 0.08. I need to shift this over. 8% is 0.08. But when you multiply, when you want to increase it, it'll be 1.08. You want to multiply by the entire 1 that's there times that whole. Now, this is what's called a scale factor as well. That means there are no units applied to this. It's just a number. It is unitless. When I multiply dollars by a number, the result is still dollars, right? What's $5 times 3? It's $15. It didn't change it into something else. So keep in mind, the 1.08 is representing percentage, but when you multiply by it, it's still a dollar amount that we had. Now, ultimately, that 8% sales tax is to your subtotal, and then on top of that, you add a tip. The tip is not applied as a part of the 8%. That's something you'd probably just have to know. So this is dollars as well, plus dollars there, and the whole total amount, I kind of ran out of room, is $13.80. I'll squeeze it in. Let me find a way. But $13.80. So that's the end result of that, which is also dollars. Obviously, we still need to solve, and I'm going to write a cleaner version of what we're looking at here. Dollars plus dollars times scale factor plus dollars equals dollars. So this is 1.08 times quantity 2 times X plus $2.50. You know I can also write that as 2.5. Then plus 3 equals $13.80. I can also write that as 13.8. Ultimately, when I solve, I'm going to figure out how much the cost is per taco. How many dollars per taco. So, listen, this is decimals. We'll just deal with the decimals. One thing we're probably not going to be able to... Oh, actually, we can. Hold on a second. So, first thing I want to... Listen, you can distribute if you'd like to. I think it's going to be weirder decimals. I'm going to first just clean this part up and talk about, hey, which way would you prefer? When I subtract 3, 13.8 minus 3 is 10.8. So I have 1.08 times 2x plus 2.5, and this equals 10.8. Now, that's pretty. You know why? You see this 108 and 108. I know the decimals are in different places, but guess what? These will divide with plenty cleanliness. Why not go for it? Let's divide both sides by 1.08. Can you recognize it? I don't know. Would you rather try it out before you distribute into this mess of decimals? Maybe. It's not a It's not an unholy mess, but it's just more. Let's make less out of it. You know what 10.8 divided by 1.08 is? It's 10. This is actually, remember, it's $10.80. Divide by $1.08, that's 10. 10. So 2x plus 2.5 equals 10. Subtract 2.5 from both sides. I mean, this is a bigger problem than it led itself on to be, right? I mean, compared to what we were doing before, this is more information. 2x equals 7.5, and we divide both sides by 2. Now, is this answer decimal? Sure, but this is a dollar amount, so this might make sense in what we do. This is what they're saying, by the way. Both tacos cost us $7.50. Both tacos cost us $7.50. So how much was each taco? Sometimes when you think money, you'll know the answer a little better. That's $3.75 a taco. $3.75. So each taco costs $3.75. That's what we found out there. So there's a lot going on in that problem. There were decimals. There was a percentage portion. The tip happens after the tax. And units and such and such. And I went toward division on this. You could have gone distribution. You should get the same answer. Okay, numbers 38 and 39 justify each step of the solution. I'll tell you what, for myself, this is something where I'm going to copy and paste what's there, and I'm just going to write inside the little box to get the answers that we want to get here. So on number 38, ready, boom, and shrink it. Okay. And enlarge it. Okay. -1/2. And it's a good thing I spoke on what I spoke on before because they're doing it here. -1/2 times the quantity 5x minus 8, and then -1 equals 6. Now, the first thing they did was what did they ask? Justify each step. They added 1 to both sides of this. Now, I don't know if they want us to literally say add 1 to both sides or addition property of equality. You know, those are kind of two different things to state. I'm going to go ahead and just say to add 1 to both sides. Add 1 to each side. Now, did they do that? You can see the 1 is gone, the -1's gone on this side, and 6 plus 1 is 7. So I'm going to say yes. What did they do next? See, what happens a lot here, if I didn't write any action in between, and I was moving along, and I was doing this with the class, and someone was inquisitive enough and didn't understand, and they asked, Mr. Robinson, how did the 7 turn into -14? Well, that's a good question. Here's another question. Where did -1/2 go? Right? So clearly, both things were affected in some way. Now, if you remember, taking half of something is also dividing something by 2. So taking -1/2 of something is also dividing something by -2. You don't have to write it this way, but what did they do? They multiplied both sides by -2 times -2 because -2 is being divided. Now, do you need to see it as underneath that quantity? Heck no. You can see it as -1/2 right here and just say multiply by its reciprocal. That's totally fine, and that's what we do. -2 over 1 is the reciprocal. Sure, cancel, 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 cancel. I don't like to say the phrase, but you're left with that. 7 times -2 is -14. That's where it came from. So what did we do? We multiplied -2 on each side. We busted the fraction. Now, they could have distributed the negative. That would have been ugly. It's possible. But they decided to bust the fraction. So I like that. I like the step. And I like that they showed it so I could say that, hey, guys, if I ever do it, then it sounds just. I'm going to add 8 to both sides. Again, where did the -8 go? Well, it added over, and that's where we got -6. Add 8 to each side. And then they divided by 5. Now, I also I'm liking what the book's doing here. They divided by 5, and although it's an exact decimal, they could have written -1.2. They had a fraction, and it's an improper fraction. I love it. Divide both sides by 5. And this is a totally good answer. As long as it's not, right, this wasn't, you bought 5 tacos, it cost, let's just say it was positive, it cost $6. How much did you spend per taco? You don't say you spent 6/5 of a dollar, you say you spent $1.20. If it's a real world problem, I get it. If they forced decimal and there were decimals to begin with, I get it. Fraction answers are good, guys, and improper fractions are fine. If this is your first time doing this algebraically and you're getting fraction answers here and there, first of all, doesn't mean no solution. I want to make sure you know that. Don't say, oh, I can't divide, no solution. That's not what no solution means. Second of all, fraction answers are fine. They are exact as long as you reduce them, and there's nothing to reduce there. It's good. See, if I got 2/3 as an answer, I'm not writing, oh, it's about 0.6. Oh, it's no solution. No, I'm writing 2/3, man. I'm writing 2/3. All right, let's do this one more time. They're going a different method on this, and I would totally go the way they're going with it. They begin by taking the 2 and multiplying into the x and 3. That's known as the distributive property. So distributive property, it's not of equality. They didn't do it to both sides. They're working on simplifying. Speaking of which, they simplified a little bit. 2 times x is 2x, 2 times 3 is 6. I'm just going to call that simplify. Simplification. They multiplied, but it wasn't something to both sides. They're doing the operation that's being asked of. So I call it a simplification step. I call this a simplification step as well, but to be very specific, I'll write CLT. What do you think that stands for, in case I do it again? Combining like terms. 2x plus 1x gave you the 3x. So they combine like terms. And from here, they are going to subtract 6 from both sides. And then from there, they are going to divide 3 from both sides. So let's write those two out. Subtract 6 from both sides. I don't really have much room. And then divide 3 from both sides. Now, this isn't one of those error analysis questions. The work they did is totally accurate, so the number's right. I'm not double checking anything, but those were the actions involved. Okay, those are my justifications. Let's move on. Oh, speaking of error analysis, number 40 and 41. Now we got to figure out the error and correct it. So describe and correct. I already see it. And normally, when they have an error, there's just one error, meaning the rest of the work is done right, but because the one error was there, the answer's wrong. So they begin through distribution, which works. It's kind of your call on what you want to do. Because they did that, I want to do the distribution as well and not say, guys, you should have done it this way. Because they could have subtracted 4 over and then divided by -2. But they didn't. They distributed -2. And they got -2 times 7, which is -14. And -2 times -y is -2y. Stop me if you think you see the answer, the wrong part. Oh, did you see it? There it was. This should be a positive 2y. A positive 2y because we're multiplying a negative by a negative. They do fall right into what a lot of people might make a mistake on. So there's the issue on that -2y. Now, is the rest of the work good for what they did based on that being negative? Sure. -14 plus 4 is -10. They added 10 to both sides and they get 6, and they divide both sides by 2 to get -3. They didn't show the actions in between. I will for the problem. However, I will go and say this. Our answer is going to be positive 3. Because what's the only difference is this will be a plus, 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 and therefore plus. Actually, are you okay with that? Are you okay with that? That the answer is positive 3 because they distributed a negative into a negative value and yet got a negative result instead of positive. Now, I'll let the work there speak for itself instead of rewriting it. Instead, the correction is now y equals 3. Y equals 3, and that comes from here. When you distribute that negative, this turns into a positive. So plus, 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 plus. All right, let's go to number 41. 1/4 times the quantity x minus 2 plus 4 equals 12. So what did they do in between here? Let's actually, I think that's the second time. I think in section 1.1 for number 41, I also wrote a 14. There's a curse there for some reason. So the first thing they did was they subtracted 4 from both sides, yeah? Okay, looks good. Now, from here, the 1/4 somehow goes away, and the 8 somehow turns into a 2. Well, what do they do with 8 to get 2? You're like, well, it's divided by 4. It sounds like they divided by 4. Yeah, but they weren't supposed to do that because this is already dividing by 4 here. You need to work opposite of it for the 1/4 to go away. You need to multiply by 4. So that was their mistake here. They divided by 4 instead of maybe they divided by 1/4, but they thought 8 divided by 1/4 was 2, and it's not. So from I'll just say they divided by 4 instead of multiplying by 4 to get rid of the 1/4 on the side of the equation with x. So let's go ahead and correct that one. Let's start from that step, though. Their -4 part's good. We have 1/4 times x minus 2 equals 8. Remember, fraction means division. This is dividing by 4 on this side. So we got to do times 4 to get rid of it. See, this is where you got to be very careful on your whole cancel. 1/4 divided by 4 doesn't cancel because you wrote the crossed out mark, right? I mean, you canceled it, therefore I guess it did. But this cancels because 4 divided by 4 is 1. But that was 1/4 divided by 4. That's not 1. 0.25 divided by 4 is not 1, right? It's 0.625. It's 1/16. This becomes x minus 2 equals 32, not 2. And you add 2 to both sides from there. We're going to get x equals 34. A far cry from the previous answer, so it was worth doing all the different stuff we have. All right, in exercises 42 to 44, write and solve an equation to answer the question. So maybe we can vocalize some of those things out loud when it comes to units, because they're not requiring we do something there. They're not requiring double checks. I sometimes go the bare minimum, as you can tell, but that's because I've done a lot. But I'll vocalize everything. The perimeter of the tennis court is 228 feet. What are the dimensions of the court? Okay, a perimeter, first of all, the court is rectangular. Second of all, a perimeter is the sum of the lengths around the court itself, so all the sides. So in being a rectangle, that means opposite sides are equal to each other. I don't know if you know that property, but I think you can understand it. If this is 2w plus 6, so is this. If this is w, so is this. So you have two options on how to write the initial setup. You can write perimeter, by the way, perimeter is 228. Perimeter equals this plus this plus this plus that. You know what else you could do is, because they're doubling up, right? This times this, this times this. This plus this is that times 2. It's 2 w's. 2 w's. And there are 2w plus 6's. So we can do this. We can do 2 w's plus 2w plus 6's. These 2 w's plus these 2w plus 6's equals 228. So that's kind of a cooler setup. We can also work that distribution from there. We could divide everything by 2 right now if you wanted to. We'll leave it. 228 equals, we have 2w plus 2 times 2w is 4w. 2 times 6 is 12. More simplification to be had. 2w plus 4w combine forces and become 6w. And we can subtract 12 from both sides. And we're getting a width out of this bad guy right here. These are all in feet. 6w equals 216. And divide both sides by 6, and w equals 36. W equals 36 feet. 36 feet of width. They asked, what are the dimensions of the court? Dimensions include width and length. Now, length must be the other dimension. If length is 2w plus 6, length is 2 times 36 plus 6. And is this accurate to tennis courts? I'm going to assume probably. I don't know if it's standard. 72 plus 6 equals 78 feet. Time to Google. What are the dimensions of a regulation size? They said tennis court. They said soccer field. Tennis court. 120 feet by 60 feet. Whoa. I guess that's a big one. Tennis courts have an overall length of 78 feet, a singles width of 27 feet, and a doubles width of 36 feet. So this is supposed to be the doubles court. I wonder what those other court things are. I think they're talking about maybe a pro court. I don't know. Maybe a pro court's bigger, because I read a couple different things on it. Okay, number 43. The perimeter of the Norwegian flag is 190 inches. What are the dimensions of the flag? The same kind of question, right? I'll leave that information as it was. So perimeter is the 190. That is the sum of all your sides. Let's do the same things we did last time. We have 2 y's we're going to add together. And then we have 2 of these things here. 11/8 y. 11/8 y. Now 11 divided by 8 is 1.375. You can double it and get 2.75. You could. I'm going to work with fractions this time, I think. Now, what I can do to begin with on this, listen, we can bust the fractions as well. 2 divided by 8 can reduce as 1 divided by 4. That means 1 times this thing is just this thing. I can write it as 11/4 y. So that's an option. That's an option. Now, I'm still not done in that stage, but you know what? Let's keep going on that. Let's play common denominator. Let's deal with this as a fraction problem. 2 is also 8/4. 2 times 4 over 4, right? And now we have 190 equals 8/4 y plus 11/4 y. Now that we have a common denominator and they're like terms, we can combine them, where we get 19/4 y. Now, how do you solve in this scenario? You multiply by the reciprocal of the coefficient. You multiply by 4 over 19 and 4 over 19. Now, this is pretty good numberage because 190 divided by 19 is 10. And 10 times 4 is 40. Therefore, y equals 40. It says, what are the dimensions of the flag? I guess y represents the width because it must be smaller than length. So the width is 40 inches. Now the length is 11/8 of the 40. 40 divided by 8 is 5. 5 times 11 is 55. So the length is 55 inches. You could do a double check. What's 2 40s? 80. 255 is 110. 110 plus 80 is 190. Was that the... Yep, that was the perimeter. So I trust it. Number 44, also perimeter. Perimeter didn't show up in the lecture portion, so these are just kind of like a new set. They're like, do you know what to do? This is kind of like home plate, only it's a school crossing sign. The perimeter of the school crossing sign is 102 inches. What is the length of each side? All right, this time I'm just going to add them straight up. Let's just do this from here. 2s is at the bottom, but check this out. There are 2 s's on each side. 2s plus these 2 s's. I'll do it more like 2 times s to show you that I'm talking about those two. Plus, and then there are 2s plus 6's, right? 2s plus 6's. Add those up, you get 102 inches. So 2s plus, I guess that's still 2s there, plus distribute the 2 this time, 2 times s, 2 times 6, you get 2s plus 12, and that equals 102. 2s plus 2s plus 2s is 6s. We're 2 steps away, right? As we've been practicing this, we subtract 12 from both sides, and then we divide both sides by 6. 90 divided by 6 is 15. S equals 15. To answer the entirety of the question, we have to say, what is the length of each side? I'm going to copy and paste the diagram. These are all in inches, by the way. And I'm going to write all around that thing. Let's hide up some materials. I don't think you get to do the same thing here, but I do. Okay, 15 is the length of these vertical sides going down, so 15 and 15, those are each inches there. 2s is 15 times 2, right, doubles, that's 30 inches. So we have 15 inches here, 30 inches here, and these were s plus 6. 15 plus 6 is 21, 21, 21. So 42 plus 30 is 72, plus 30 is 102 inches. That works out. That's the unit, by the way, for inches. Number 40. Oh, where are we? Number 45. Comparing methods. Solve the equation 2 times 4 minus 8x plus 6 equals -1 from using method 1 from example 3 and method 2 from example 3. Which method do you prefer? Explain. So the two different methods involved, guys, are distributing the 2 into here and simplifying the whole side before doing anything, or ultimately dividing that 2 from the answer when all said and done. Now, I'm going to tell you straight up that I already know I'm going to prefer method number 1 of distribution for this particular problem. And that's because, wait, is this the same problem as the one? I don't think it is. And that's because this number ultimately won't result in an even number. And when I divide a non-even number by 2, well, you know, it's a decimal. But we'll get there. We'll get there. Let's start with the distribution one, the one that's probably the better off version. 2 times 4, 2 times -8x. 8 plus 6. This is the example where I wanted to say you do 8 plus 6, not 8 minus 6, right? So 8 plus 6 is 14. The 16 is still negative. You have negative 16x, you have a positive 14. And I'm now going to subtract 14 from both sides. Now, will this method stave it off from the answer being a decimal? No, it's still going to be a decimal. And we get negative 15. Then we divide both sides by 16, negative 16. And what, no solution? No. Get the decimal? No. 15 over 16. It can't reduce. It can simply, positive 15 over 16. That's just the answer. That's one version, right? If you do want to write the decimal, because here's the thing. On the other side, guys, we might end up writing the decimal version. So what is 15 over 16? Is it at 0.9375? I think it's 0.9375. We'll figure it out in a second. Let's subtract 6 from both sides this time. Here's the second version. Get this quantity by itself by doing minus 6. Minus 6, right? When we do minus 6, we have 2 times 4 minus 8x equals negative 7. Now, instead of distributing the 2 into here, let's divide the 2 out. 7 can't divide by 2, Mr. Robinson. Well, it can divide. It's just not an integer. It doesn't divide wholly. So, that's probably why you don't like to do this method. Now, this time I'm going to write it in decimal form just to show that they're still equivalent. This is negative 3.5. Let's continue trying to solve for x. I'm going to subtract 4 from both sides. It is a positive number. On the side with the negative 8x term, 8x is still negative. Keep that in mind. It was here too, the negative 16x. This is negative 7.5. And now we're going to divide both sides by negative 8. Now, this is one where I wouldn't want to have the answer 7.5 over 8. When I write a fraction, I'd want integer over integer. You could double them. You would get 15 over 16. I think now's the time that I check and see what that number is, though. I think it's 0.9375. It's 0.9375. So x equals 0.9375. Guys, it's the same answer, which is good. It's good. You wanted that. Same Z's. Now, which method? Which answer do I prefer? Probably the fraction. Which method do I prefer? Method number 1. Explain. Now, this is your choice, right? For this problem, for this particular problem, I prefer method number 1 of distribution because the fraction / decimal is saved until the very final step of the problem. Whereas method number 2 gets into a decimal from early division because the right side of the equation, because negative 7 wasn't divisible by 2. If it was divisible by 2, hey guys, all bets are off. You do which one you prefer to do, honestly. I like both. It's just really problem dependent. Okay, number 46, problem solving. An online ticket agency charges the amounts shown for basketball tickets. The total cost for an order is $220.70. How many tickets are purchased? Okay, so number 46, we have the information up there. I'm not going to copy paste it. There's a processing charge and convenience charge. I think we can state, the per ticket. Convenience charges per ticket. I hate convenience charges, man. I don't know what they're charging. I know it's convenience. I don't know what's like, where's the money going to you for that? What is your, anyway, different thing entirely. How many tickets are purchased? Number of tickets is what we're missing out on. So we have $32.50 per ticket times the number of tickets. Notice 50 cents and 0.5 are the same thing. Convenience charge will be added per ticket as well. $3.30 per ticket times the number of tickets. Processing charge is $5.90 per order. We make a single order. There's the $5.90. And total this equals $220.70. Now, in case you're annoyed with me not putting the added 0, for me it's more than needs to be written for the original problem, part of the problem. There are sometimes I'll write it, and other times that it just gets in the way. For now, it's kind of in the way. Everything's ending in a 0 anyway. Why not just get rid of them? Heck, you can do this. You don't like decimals? Multiply everything by 10. Did you know that multiplying something by 10 moves the decimal place to the right? All of these have a single decimal. We could do this. 325x plus 33x plus 59 equals 2,207. Listen, there was a cost to this, not like ticket cost, whatever. There was a cost to this. The numbers are bigger, but maybe you'll like it more. What's 325 plus 33? Maybe you like that more. Anyway, you combine like terms here. We get 358x. Actually, in some ways, I might have liked it just as money more now that I'm looking at it. You could subtract 59 from both sides. And we get 358x equals, and we're hoping the final answer is like an exact number, right? Otherwise, things would look a little screwy. That's 2,148. Then you divide both sides by 358. Now, if I were to wager a guess, that would probably be 6. Because it's probably supposed to be a whole number, right? Unless I did any math wrong. Let me just do that. 2148 divided by 358. I'm getting 6, yes. So x equals 6. That's the number of tickets that were purchased. So x equals 6 is our way of saying 6 tickets were purchased. There's our setup. There's a solution. More than one way to solve. That's how I went about it. All right. Okay. For those exploring the word problems with me, how are they doing? Hopefully pretty good. Okay, number 47, making an argument. You have quarters and dimes that total $2.80. Your friend says it is possible the number of quarters is 8 more than the number of dimes. Is your friend correct? Explain. Let's just go based off your friend's setup. Let's work it out. Now, there is value to quarters and dimes that are separate from each other, right? The number of quarters is 8 more than the number of dimes. They didn't state that means there are 8 quarters and 1 dime, though. That's the part you have to be careful with. So if the number of dimes, if the number of quarters, 8 more, not 8 times more. I'm sorry. I apologize. If the number of quarters is the number of dimes plus 8, then you can make an equation that says the number of dimes times the value of each dime, which is 10 cents per dime. I guess now I'm putting the 10 just to emphasize that was its value, plus the value of each quarter times the number of quarters. The number of quarters in this case to me is D plus 8. And that equals $2.80. Now, this is also one of those instances where if you don't like the representation in terms of dollars, because here's the thing, what we could do here is, again, get rid of the decimals and turn this into cents, multiply by 100. If I multiply everything by 100, you shift the decimal place 2 places over, and this becomes 10 cents per dime times the number of dimes, plus 25 cents per quarter times the number of quarters equals 280 cents. So now it's a cents equation. Cents, cents, and cents. Anyway, all I'm saying is no more decimal. I could divide by 5 as well, right? There are a lot of things you could do here. It's just, that's where you want to work the math to your advantage. It's kind of your call, your question. 25 times D plus 25 times 8. I wonder if this is the easiest way to do the question. We probably could have done substitutions, but because it said 8 more, we don't know how many there will be. That's the thing about the situation. We need to see what this will become. Bottom line, if D is not an integer, if D is a negative number, if it's a decimal value, I assume I did the math right, then maybe that doesn't work out. 10D plus 25D is 35D. If I subtract 200 from both sides, I get 80. And I divide by 35, and this isn't value, guys. This is number of dimes. 80 doesn't divide by 35 evenly. Let me go to the calculator here. 80 divided by 35, 80 divided by 40 would work. 80 divided by 35 is that number right there. Because it's not an integer value, I'm guessing that doesn't work out for its value as a whole, right? So you couldn't have 8 more quarters than dimes because that scenario doesn't work. The dimes are not a whole number. So no, you cannot have this amount. When setting up and solving an equation with that scenario, The number of dimes is not a whole number. Now, a whole number by definition actually literally means all positive integers and 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So me saying whole number actually satisfies everything I have to talk about. It could have been 0 dimes, right? If we have 0 dimes and 8 quarters, that's still 8 more quarters than dimes, but it doesn't add to $2.80. Okay, so that doesn't work out. I lost my thing. Once I went to the calculator, I lost my other window. I know it's up for you, but I can't see it. Here it is. Okay, number 48, thought-provoking. Whoa. You teach a math class. I do. And assign a weight to each component of the class. I do. I really do. The things that the things that parents don't understand. You determine final grades by totaling the products of the weights and the component scores. Choose values for the remaining weights and find the necessary score on the final exam for a student to earn an A in the class if possible. Explain your reasoning. Okay. So to give you information on this, and this is how this stuff works. Class participation, students have a 92% in-class participation, but that accounts for 20% of the overall weight. So when they add up everything in their total, 18.4% of their overall grade that they got is coming from this alone. Now, this is an open-ended thing where homework can come in and exams and final exam kind of stuff like that. So let's do a lesser weight here for homework. I don't know why class participation is so high. Let's give homework as just 10%. You know what? I'm going to totally copy and paste this over to my side. Because on this side of my screen, I kind of have to use the mouse. On this side, I get to use my stylus. So let's bring it over. Bring it on over. Okay. So let's do 10% for homework. I don't know why I'm really belittling homework. It's fine. Class participation is a little too high, guys. You better participate in class. So 95% times 0.10, that equals 9.5%, I guess is the way that you can work that out. Midterm exam and final exam. Let's see. We have 70 more percent to work with. Let's make the midterm less than the final. Let's make this 30%. Therefore, we'll make the final 40% as a whole, okay? Now, we're going to do 88% times 30% of the 88%, and that's going to be 26.4%, I believe. So we want to at least get 90% in the class, okay? This is our unknown right here. We need to figure out what this final exam is going to be. I guess we kind of have two unknowns. We need to figure out what our final exam is for this to add up to 90% with this. So I take it back. This isn't really an unknown. We just got to do some subtraction on this one here. So, okay, well, I take it back. We'll do an X, we'll do a Y. Okay, so our first one is we have 18.4 plus 9.5 plus 26.4 plus X equals 90. We need to add up to 90%. This is kind of the way I'd do this, but kind of not. I'd write things a little bit differently here. Oh, you know what I could do? I take this back. We could just do 0.40 times Y. 0.40 times Y. Okay, that's how I would do this here. So instead of X, actually let's call this an X. Sorry about that. This is totally how I do the problem. I'm like, I wouldn't separate it into two different parts like this. Totally. Now, I'm going to call it 0.4. I'm going to call it 0.4. I'm not a fan of trailing zeros personally, not unless I need them. Here I totally don't. I could multiply everything by 10, but I'll leave it. All right, 18.4 plus 9.5 is 27.9 plus 26.4 is 54.3. I think. I hope. I'm doing this stuff in my head. 90 minus 54.3 is 35.7. 35.7. Okay, so the idea here is they're asking, is it possible to earn the 90% given the weights that I assigned? And because this is open-ended, it depends on what you set up. So maybe it's not. It just depends on what you did. I believe, based on the numbers that we're seeing for midterm class participation and homework, I think it's more than possible. Now, what would make it not possible? I guess we're saying if this grade, when I divide by 0.4, if this ended up being more than 100%, assuming no extra credit, stuff like that, then I guess it's not possible. 100% is the maximum we can get, and as long as we get 90%, we're good. So I'm dividing by 0.4 to do this. By the way, I didn't write the step in between. I very much apologize. See, in the future, I will be skipping some actions in between, but you might say, how did I go from one step to this step? I subtracted 54.3 from both sides of the equation. Sorry, I got kind of into the equation itself. Okay, so now I'm dividing both sides by 0.4. I think that answer is going to be somewhere in the mid 80s, high 80s. It's going to be around 88 something. So let's go to the calculator. Let's do 35.7. Sounds like a radio station. Divided by 0.4. Very high 80s. 89.25. So x equals 89.25%. That is your final exam score. You're going to need to get at least a 90% in the class. So is it possible? Yes. It is possible to get an A in the class given the grades and weights, because the final exam minimum is less than or equal to 100%. Less than or equal to 100%. As long as it's that or less than, then it's possible to do, and that's what we got. Now, you might have chosen different weights. You might have gone about it a different way, and I hope I did my numbers correct in my calculations. I did all that in my head, so we're good. Okay, let's move on to number 49. Reasoning. An even integer can be represented by the expression 2n, where n is any integer. Yes, that makes sense. If I have a number, whole number, right? 2 doubled is 4. 3, odd number, 3 doubled is 6. No matter what integer you have, once you double it, it becomes even. Find 3 consecutive even integers that have a sum of 54. Explain your reasoning. Well, let's take a look at this. 2n can be my first even integer. The next integer after that consecutively would be 2 more than that number. So the next number would take this number and add another 2. And the third number would be that number and another 2 on top of that, which is 4. So here's, let's say this was 2, 4, 6, right? 2 more than 2, 4 more than 2. These add up to 54. This can be our setup. Now, the parentheses aren't doing anything. It was just helping me group what they were. So I can get to do 2n plus 2n plus 2n. That's 6n. 2 plus 4, which is 6. And this is 54. They do not want you to use trial and error. They want you to set up and solve algebraically. That's exactly what we're going to do. Subtract 6 from both sides. You get 6n equals 48. Divide both sides by 6. You get n equals 8. So the question was, what are the 3 consecutive integers? The first integer was 2 times 8, which is 16. The second integer was 16 plus 2, which is 18, and the next consecutive integer is 20. Explain. The math was the explanation in that case. Does that work? 16 plus 18 is 34. 34 plus 20 is 54. Yes. And they're all even. Number 50. How do you see it? The scatter plot, this thing, shows the attendance for each meeting of a gaming club. The first meeting had 18 students. The second meeting had 21. The third meeting had 17. The mean attendance, oh yeah, we have to do mean. The mean attendance for the first 4 meetings is 20. Is the number of students who attended in the 4th meeting greater than or less than 20? Explain. I'm going to assume it's greater than, because estimate the number of students. Okay, I think they don't want us to actually solve this first time through. I think they want us to look at it and ask ourselves what it would be. Now, one thing I'm going to do is kind of just draw a line here to represent if this is 20, I guess kind of like that, right? If this is 20, the 4th meeting, to average these things out, we need another one above there. We had one that was above 20, and the other 2 were not only less than 20, but they were more less than 20 than the one was more than 20. So is the number of students who attend the 4th meeting, the number of students who attended the 4th meeting needs to be more than 20. How much exactly, we'll figure it out. More than 20 to average 20, because there are more, the meetings with less than 20 students have a greater separation from 20 than the one meeting with more than 20 students. I mean, that's without calculating anything. That's just visual. That's thought and scale and numbers, right? It was the same thing for that math final kind of question that we had as well. It's just making sense of it. It says estimate the number of students who attended the fourth meeting. I don't, if this is where I think we do the math. So this is 18 plus 21 plus 17 plus this unknown number that we have. And when we average this out, we will divide by how many meetings there were, 4, and this will end up being 20 students per meeting. This is where we have to solve for x. 18 plus 21 is 39, plus 17 is 56. So we have 56 plus x, all divided by 4, equals 20. This is where we can solve using 2 more steps. I should multiply both sides by 4 since that's the last thing. We divide to get 20. This actually shows how many students there were in all 4 meetings in total. They might be the same students, but the point is there were 80 students in total for all 4 meetings. And if we subtract 56 from both sides, then we'll get how many students there were in just that 4th meeting alone, so that you can then get that average of that. And there would be 24 students in the 4th meeting. You can see that we really had to up the number of students to meet that average as a whole. So there's that. They state, describe a way you can check your estimate in part B. I can accumulate the average. Literally, I can do this right here, but that's just going back to the equation. So it's a double check. So I don't know, unless they're asking for something else. But take the average of 18, 21, 17, and 24. 18 plus 20, those add to 56. 56 plus 24 is 80. 80 divided by 4 is 20. That all works out. So that's what I'm going with. Even though my equation set that up, solved that way, I suppose that it's still working that. Okay, guys. Did it say, what did it say? The mean attendance is 20. Okay, I didn't know if it was 20 or at least 20. All right, 6 more questions. They're all within the same set. We'll see if these are easy, hard, whatever. We're just past the 2-hour mark, so let's wrap this thing up. In exercises 51 to 56, the letters A, B, and C represent non-zero constants, numbers that are not zero. Solve the equation for x. Okay, all these are what are called literal equations. They mean get x by itself, even though you won't have an official answer in it, like a number. It's not going to say x equals 5 or anything like that. You just work off what's still there and do the best you can. B is multiplying with x, so we divide both sides by b to come up with that number, that result. So x is negative 7 over b. I mean, that's the result. If b was 3, it would be negative 7 over 3, right? That's the idea anyway. But that's the answer. So these are all literal equations. This is solving for x in terms of b. We're about to solve for x in terms of a on number 52. X plus a equals 3/4. Weird numbers are going to be had, I suppose, because they want them to be. We can subtract a from both sides. Now, why do we subtract a? Because it's adding with x. So x equals 3/4 minus a. Remember, these do not combine. They are not like terms, and that's the result. If a was 3/4, the answer is 0. You know what I mean? So it is what it is. Number 53 is a little bit trickier because it takes 2 steps, and yet we can't combine unlike terms. So keep that in mind when we're doing this. A times x minus b is 12.5. And don't forget, a is multiplying with x before b is subtracted. I'm going to add b from both sides to begin with, just in the very sake that, we got to get this term by itself, and these don't combine. And you know what, guys? This stuff will be very, very important when we start to solve linear equations. These are linear equations. When we start to rewrite equations in different forms, slope intercept, you might have heard that phrase, slope intercept form. Now, when we divide by a, because that's what we got to do to solve for x, right? You would divide the entire thing by a, both terms. You could write them separately as divided by a, divided by a, divided by a. But it's not just one term that divides by a. Both of them do. Now, this is an acceptable answer. I'll leave it like this. 12.5 plus b all over a. Part of me wants to write b plus 12.5 because I like the letters first. But that's fine. We're good. We're in the right spot. Number 54 is no different. It's a different question, but it's no different as far as setup and solving. There's a that's still multiplying with x, which means eventually I'll have to divide by a, but not from the jump. We have to do it after we move this b term over. Because it's added, this time we'll be subtracting it. C minus b, it's not 20 or anything. They just don't combine. They are unlike terms. C minus b is all. Now we divide by a in the same light as we did last time. Both terms divide by a like that. So x equals c minus b all over a. Now we could substitute numbers in there, have some fun with it. C is 20, b is 8, a is 4. You'll get an answer. But that's not what they're doing here. 2 more questions. Number 55. Okay, this one's a little bit trickier, and I don't know what's expected for you to know and not know. So I'm going to introduce a new word to you, and that word is factor. Factor is the opposite of distribution. I want you to think about if I had to multiply something into both equations. Notice how both of them have x's. Look, both of them have b's as well. Let's ignore that. Oh, you know what? You know what? Ignore what I said. We're not factoring. We're not factoring. You won't have to know factoring until another time. Save what I said. Nip it in the bud. We are good. Okay, let's do that again. I want to combine like terms. 2 times b times x and -1 times b times x are like terms. They both share the bx multipliers. 2 minus 1 is 1. You're left with 1 times b times x right here, or just bx. Forget what I said about factoring. We're good. All right, b is multiplying with x. We can divide both sides by b, and we will get x equals -8 over b. Okay, that's fine. We're good. Got it. All right, last question, number 56. We have c times x minus 4 times b equals 5 times b. This is where, even though the final answer might not be a single number, and even though some things won't be able to really infuse and combine, it looks like something else will be able to work itself out, though, just like the last problem. If I add 4b to both sides, these can actually combine. 5b plus 4b is 9b. So c times x equals 9 times b, and if I divide both sides by c, then I'll get a final result. So something did clean up a little bit. It's not perfect. I get 9 times b over c, but it's better than a couple separate terms than we had before. And that's the last one. All right, guys, that'll do it for this one. This is Mr. Robinson. Thank you so much for watching. In this section coming up is section 1.3 for, I don't know what the name is. Let's see. Section 1.3 is on solving equations with variables on both sides. This is where I'm going to talk more strategy on making variables positive when I feel it's best to. So thank you guys so much. Take care, and I'll see you in the next one.